What we're going to show now is we're going to take two different lens shapes. We have two convex lens cutouts, if you want to call it that. And this one is very thin, so it has a long focal length. This one is fat, it has a short focal length. And again, I am using a straight line source that I could adjust and make them as parallel as possible. Lights. Now, there are four light rays here, and we notice that as I put the first one in, we get a focal length, I don't know how far that is, maybe 4 or 5 centimeters. This one is definitely longer, and that fourth ray doesn't work very well, so I'm just going to cover it up. So we have a long focal length, short focal length. But what if I keep the two and I get a perfect focal point? Pretty good, right there. All right. Then I take the other one and I put it with it. Now, if we were to take the time to measure this, we would find out that the first distance from the fat convex lens to the focal point is the focal length that we would have measured beforehand. And from here to the other one is the focal length that we would have measured beforehand. Because the definition of a focal point and focal length is where all the parallel light rays cross. Well, it also turns out that if you put a light at the focal point, it will produce parallel light rays after it goes through the lens. This is, by the way, exactly how the lights on a car work, the headlights. You put the light source at the focal point of the parabola and it shines out parallel. Stop.